So, good morning. In our last class, we were discussing the various concepts related to internet applications. So, we discussed HTML, XML, and DTD. So, DTD stands for Document Data Type Definition. So, we also saw the syntax for defining the DTD. So, DTDs will decide whether an XML is according to the format or not. So basically, which means the format for XML file is defined through DTD. And using DTD, we will decide whether an XML file is a well formed, valid, or it is invalid. So for a given example of a DTD over here, so an element basket uh, that inside can have any number of cherry elements. Then the cherry elements, it is empty, and cherry is having an attribute list, favor, flavor, and it is a compulsory. So based on this DTD, if we look at the XML files, so we have a basket, we have a cherry, and we have a flavor. That is good. But if you observe, this flavor is a character data. So if it is a character data, it has to be in a single quote. So if quotes are missing, then it becomes invalid. So, or in other sense, we also call it as a not well formed. So other example over here, um, it is well formed but invalid. Well formed in the sense it is with regard to the structuring, that is a very opening tag having a closing tag. So here, the job, location, and job, these are nowhere related to the DTD file. So in DTD we have only basket and cherry elements, whereas here we have job and a location. So that's why it is invalid. So next, here another example, basket cherry with an attribute flavor, which is a compulsory in cherry, and basket should have at least one cherry element. So, and this attribute is also having a single code, so which makes it well formed and valid. So this way, using a DTD, we can specify how many elements can be present in a XML, and which element acts as a parent, and how many child element it can have. For each element, what are the different possible attributes, and which attributes are compulsory fields. So all those things, uh, that in a sense, the tree structure of a XML, and that is a core structure, it is defined in DTD files. So when given a DTD and an XML file, so we should be able to identify whether it is well formed and valid, or it is invalid. So more and more standardized DTDs will be developed. So using some of the languages, math, ML for mathematics, chemical markup language. So these are the few well-formed DTDs where the chemical structuring, all those things can be defined. So this XML allows lightweight exchange of data with same semantics. So this XML way of representing data, it is alternate to databases. So if you want a lightweight data, we want to store say 500 student uh, data. For that, instead of going for a database, so we can use a XML. And in an application, so if only 500 students are sufficient, then managing a database will be a complex. So otherwise, so we can store a XML file. So XML is simply a text file where everything, each element, attribute, values are marked up. So that text file size is also less compared to database, and maintaining it also, it is easier. Most of the mobile apps which we use in our cell phones, they use a lightweight data in the XML format. So if you had routed your cell phone and checked the files on the specific folders, you can see lot of XML files. So, and for these XML files, sophisticated query languages also exist. So we call it as XPath and XQuery. So XQuery is the query which runs on an XML tree structure and gets the required result. So XPath is a path from the root to that particular element. So we can define or identify an element based on its path. So which helps us even more to travel in the XML tree format. So the various components of data intensive systems means the application that require data lot of data to be stored, retrieved and communicated or transferred from one system to another system. So these kind of data intensive system requires functionalities such as data management, application logic, and presentation. So, data management is completely storing, retrieving the data or communicating. Application logic is a business logic, how to process the data or what domain that the application is serving, whether it is a healthcare or a payroll system or a college database or stock market analysis or whether it is a financial data, anything. So depending on that, application logic changes, and presentation is how actually data or the application looks for an end user, whether we are displaying the data in a table, graphical format, whether we are displaying the data in a form. So how we want to, or in a statements. So how the data is presented. So that forms the presentation functionality. The system architecture will determine whether these three components all reside in a single tier or a single layer, or it is distributed across the several layers. So based on this, whether these three functionalities are present in a single tier or a single layer or two layers or three layers, we have a different kinds of system architecture. So the first category is the single tier architecture. So in single tier architecture, all the three functionalities will be combined in a single tier, and usually it is used on a mainframe systems. So user can access only through the dumb terminals, or system will be there, only user can connect to it and use the system. So that is the mainframe applications. So those kind of terminals are also called as dumb terminals, because those terminals cannot do any processing on their own. So all the processing happens on those mainframe machines. So the advantage of single tier architecture is its main is easy to maintain and administer the data, because everything is available at a single end. So the only way we need is a client access to that mainframe machines. But the disadvantage of the single tier application is today users expect graphical user interfaces. Graphical user interface means, so users want to interact with the application using the text box, buttons, radio buttons, combo boxes, drop downs, what we call it as a selection box, list elements. So a graphical user interface is required. For example, icons, you double click on the icon and the application gets open. But if it's a command line interface, then we have to type the command to open an application. So just like how we differentiate between a Unix system and a Windows system. So centralized computation of all of them is too much for a central system. So more data, more complex. So single machine has to perform all those tasks. So that becomes quite a bit complicated in a single tier architecture. So single tier architecture means the three functionalities, that is the application, logic, presentation, and data management. So all three in a single layer. So next, the two layer concept. See, the two layer concept or two tiered concept is often given a name, that is client server architecture. So if two tiers are there, one tier is called as client, another tier is called as server. So here there will be a clear cut division of work. So clients will be very thin. At the client end, only graphical user interface is implemented. Server implements the business logic and data management. So just take an example of our social media accounts or a Facebook. How do we log in or get into this Facebook account? It is just through the browser. So in the browser, there will be a text box. We will type the username, we will type the password and click on a button. If both are correct, then we will be redirected to our home page. So this is a classic example of being a client. And here only the user interface is implemented at the client through a browser, and all the activity of what post needs to be displayed on our home page, whether our whatever posts are mm, multimedia, uh, photos, videos, whatever we posted, how how to store them and retrieve them. So all those things are implemented in the server logic. So in server architecture, so client will often be thin, and they will predominantly doing the graphical user interfaces. So again, another example we can have, that is a thick client. So client implements both the graphical user and the business logic, whereas the server implements the data management. So this is also possible. So where business logic can be pushed to the client. So an example of this kind would be the applications that we install on our system, like we can install uh, Google Meet on our systems. Of course, there is a browser interface. Separate apps application can be installed. So that application manages both the user interface and the logic. So logic means controlling our microphones, processing our logins. So all those things it can manage on its own, but only for the data it connects to the server. So those applications, or maybe the Skype application, or if we are using the stock market applications of our specific brokers, they ask us to install some softwares through which we access our accounts. So that is again the thick client. So in client and server architectures, so we have two ways, that is where a thin client means the only the presentation part is at the client, whereas the application logic and data management is at the server side. And in thick client, the graph presentation and application logic is at the client, whereas the data management is at the server side. So there are few disadvantages of any technology. So the disadvantage of thick client is there is no central place to update the business logic. So if business logic needs to be updated, then all over wherever that particular application is installed, we have to update it. Just like our Android applications ask us to update. So business logic needs updation. Security issues, server needs to trust the clients. Access control and authentication needs to be managed at the server. So clients need to leave server database in inconsistent state or in consistent state. So encapsulate all database access into stored procedures. So direct access to database cannot be given because business logic is there on the one side. Um, so data is on the another side. How do business logic access data? So direct access cannot be given because that will lead to a security issue. So stored procedures has to be given. So they do not scale more than 100 clients. So scaling means how many clients can at a time access the server. So large data will be transferring between the server and the client. So because at a time how many clients are get connected, that is again restricted. So more than one server creates another problem because X number of clients are there and Y servers are there, then the number of connections will be X into Y. So this is a problem when we have a thick client. So the next kind of architecture we can have is the three-tier architecture. So three-tier architecture means all the three different functionalities will be in three different tiers or layers. So presentation layer, middle layer, and data management tier. So in presentation tier, it is a client program. Yes, our browser. Middle layer, the application server. Data management will be done by a separate database system. So all the applications will be hosted or presented through a browser. So whatever we use on our browser system, almost all of them follow the three-tier architecture. Because in client we cannot write the business logic. We can only present the data based on the user action. We can modify the data or process it at the business logic. Then the result can only be displayed back on the browser. So presentation tier provides a primary interface to the user, that is end user. So the user needs to access the different display devices, like we can access browser in our personal computers, cell phones, tablets, voice access. So different way this can be accessed. The middle tier implements business logic, implements complex actions. It needs to maintain a different steps in the workflow. It has to access different data management systems. So which means multiple databases it needs to connect. Data management tier. So if there are more than one database management system, so then this data management tier has to maintain all those databases. So consider an example of airline reservation. So if you want to book a airline ticket, so what are the different tiers we can do? We can build a database system. So now in database system we have to store the details of the airlines, how many seats are available, customer information we need to capture, and which customer has booked to which flight at which time, and the billing details. Once the flight departs, we have to again maintain whether the customer has boarded or not. So all those things will store in a database. So this becomes the number of tables that are required in this particular airline application, and their attributes, relationship between the tables. So all those things will become part of database system. And in the application server, we will put the logic to make the reservations, to cancel the reservation, add a new airline. So in application logic, what happens if a customer wants to book a airline? So what he will just give, he will just put the date, he'll put the source and destination. Then the application, based on the date, source, and the destination, needs to find which aircraft is there, and it has to list the departure times for each airline along with the fare. Then the customer will decide whether uh, he will choose which one. Then if there are any discount offers going on, then the price has to be varied. So this all these logic of information has to be maintained at the application server. Then the client program. So this client program is nothing but a browser, maybe a lightweight app. So this will provide a login to different users. This will display the forms, and the output should be human readable. Most probably all the information will be displayed in a tabular format. So just like how we book the railway tickets on IRCTC, so it has to provide a login. So these activities in airline reservation can be divided among the presentation tier, application tier, and the database tier. So consider one more example, that is course enrollment. So we are building a system in which students can enroll in the courses. So just like imagine we have uh, many online courses, course through Coursera, or many MOOC courses are available. So here in the database side, we will maintain the student information, their personal details, course informations, instructor information, course availability, prerequisite for a particular course. So all those things will be maintained in a database. So in application server, we need to provide a mechanism to add a course, to drop a course, to create a new course. There should be a possibility for a student to enroll into a course. Once the course is completed, assignments should be given, assignment should be evaluated, its result must be stored. So if everything goes well and the student clears the assignments, then certificates needs to be issued. So all those things will become a part of application logic, and it will reside in the application server. And on the client side, different users must be able to log in. A student should be log in, instructor or faculty should log in, or other maintenance staff must log in. For each of them, it has to display different forms in human readable format. So these activities can be divided among the different tiers of three-layered or three-tiered architecture. So the technologies that are used on three different layers, so include, so at the uh, client side, The technology on a web browser includes HTML, JavaScripting, and XSLT. So on the application server, so application server can be a Tomcat server, Apache server, or many other servers are available. And in order to write the application server logic, so JSP, servlets, cookie, and CGI programming is used. Many other languages can be used in the application server that includes Perl, PHP, Python, others are there. In database systems, uh, we can use stored procedures, XML, or we can use the standard SQLs. So that is a programming part. So advantages of using the three-tiered architecture involves the so the various advantages of using three-tier architecture involves the heterogeneous nature. So which means that each tire can be independently maintained, modified, or replaced. Technology in that particular tire can be changed irrespective of changing the other two. So here the clients will be very thin. So which means the presentation layer at the client, it's a web browser, and we know don't need any updations at that particular end. Integrated data access, so several data systems can be handled transparently at middle layer. So there will be a central management of connections. So scalability, so it represents a replication at middle tier which permits to scale the business logic. It includes if an application is capable of handling 500 clients today, so if it has to be upgraded to handle 2000 clients, so that ability should be there. Or if some additional things needs to be added, so it is possible if we follow uh, three-tier architecture without having to change the other two layers. So software development is also modular. So business logic can be centralized. If it is centralized, then it is easy to maintain. So interaction between tires can happen through well-defined APIs and can be reused for different components. So this is regarding the different aspects of a three-layered architecture. So we shall study in detail about all the three layers. So starting with the presentation tier. So the functionality of the presentation tier is to primarily provide an interface to the user to interact with the application. So it needs adaptation to different devices because a client can or client should be able to access the application in different devices. So its functionality should be very simple. So such as validating an input, for example, validating the format of an email ID or format of a mobile number or maybe even name. So basic things can be included in presentation type. So here we will be studying the HTML forms, JavaScripting, and style sheets. So HTML forms, uh, here we will study how to pass the data from the browser to the middle tier, and in JavaScript we will study simple functionalities, how we can validate the data. So style sheets will decide how data is presented on a screen. The same information, can we put it in a table or coloring? All those things are decided by style sheets. So we'll start with discussing this HTML forms in our next class. So here we will be studying all of this with regard to uh, Java language, or how to accomplish these things in a Java framework. So we can stop here for today's class.